Lesson 11.3, simplifying rational expressions. So we were introduced to rational expressions yesterday and what they look like. Now we're going to take that a step further and simplify them. Just like simplifying fractions, you can't leave any common factors on the top and the bottom. You have to cancel them out. That's what simplifying is. So our objective today is to identify the excluded value from the domain of a rational expression, and we have to simplify a rational expression. So okay, so what we are doing is we are simplifying. You cancel out any common factors from the numerator to the denominator. You should always factor first and then cancel out any factors. We also have to name excluded values and then simplify. So if we're looking at this first part, you guys really could do this back in pre-algebra with the exception of the excluded value part. Okay? What we have listed there on number 1, 32x to the 5th y to the 2nd over 4x y to the 7th. That is a monomial over a monomial. You have simplified these in the past. Okay, you have simplified these in the past. Now, excluded values. Here's what we're talking about, just like yesterday. What would make that denominator be 0? Well, it looks like to me in number 1, we can't just worry about the x because there's also y's in that denominator. Do you see that? And there's nothing other than they're all being multiplied together. So in this one, the excluded values, x equals 0 and y equals 0. If either one of those things happened, this problem would be completely undefined. Excluded values are values that you really don't want those variables to be. So the excluded value would be as if x was 0 and y is 0. And it goes back to those problems that we talked about where it says assume that x or the denominator is not 0 or x is not 0. It's these same things. Those variables cannot be 0. That's why they're called excluded values. You want to exclude those. Okay, now simplifying this monomial. The 32 and the 4 you would simplify like you would any other fraction. You'd cancel out what they have in common, which would be what? 4. You divide them both by 4. So the bottom would become a 1 and the 32 would become 8. So I'm going to start this problem over here like this. I'm going to have an 8 on top. I'm not going to write that 1 on the bottom because if it would just be a 1, then we wouldn't write it anyway. Okay. The x's. There's 5 x's on top and 1 x on the bottom. How many can I cancel out, Olivia? X to the 4th on top. So we can take this full one away, and the 5 would become a 4. So x to the 4th on top. And then the y's. There's 2 y's on top and 7 y's on the bottom. How many can I cancel out? 2 of them. So the ones on top are gone. How many's left on the bottom? 5. Y to the 5th. So that is the answer. 8x to the 4th over y to the 5th, and your excluded values are x equals 0, y equals 0. So those are if there's a monomial over a monomial. Okay, we've already done that. The majority of this today is going to be the new stuff here, though, where you have a binomial and trinomial. They could be both binomials, both trinomials, whatever. Over here on the right, this is the steps that you should follow. These are the steps you should follow. First of all, factor everything. Factor everything. Second of all, you find the excluded values. and then simplify. Don't simplify first and then expect to find the excluded values, because if something canceled out, you will miss that excluded value. Okay, so here's what's going to happen. I've got 4x plus 4 over x squared minus 5x minus 36. Here's what I would do. Right there where it is, the 4x plus 16, is there a greatest common factor?
Yes.
What is it? 4. So right here, I'm going to say 4, and then I'm going to take times the quantity, x plus 4. So it's no longer 4x plus 16. It's 4 over x plus 4. X squared minus 5x minus 36. No greatest common factor, so my two sets of parentheses. Negative 36 is not a perfect square, so that way I know it's not a perfect square trinomial. So we got to factor by trial and error. What's the square root of x squared? X and x. Okay, the minus in front of the 36 means what? Different signs. We need the factor pair of 36 whose difference is 5. What would that be? Megan? 9 and 4. How do I know which one goes where?
The biggest one.
The biggest one needs to go with which sign?
Subtraction.
Yes, because of this sign right here, I know the 9 has to go with the minus. So plus 4 minus 9. And I just test my outer inner. My outer is negative 9x. And my inner is positive 4x. And therefore I get negative 5. So I know this is it. So it's no longer that trinomial. It's that. Okay, excluded values. What are the two values that x shouldn't be? So you should do this. You should say x plus 4 equals 0. And x minus 9 equals 0. Each factor in the denominator needs to be set equal to 0. So x is negative 4 and x is positive 9. Those are my excluded values. Now my common factors. Common factors are individual numbers, individual variables, just like in example 1, or sets in parentheses. Here's what I'm trying to say to you. I can cancel x plus 4 with x plus 4. If, for example, let's just do a little side note over here. If there was a 4 with something else over an x plus 4, you cannot, and this is really, really important. Everybody look at the screen. You cannot cancel this 4 with this 4. That isn't allowed. Down here, that x plus 4 is a set. It is connected. X plus 4 can only be canceled with another x plus 4. The individual 4 can only be canceled with an individual 4 or a multiple of it. But it just so happens in our example at number 2, it has an x plus 4 on top and an x plus 4 on the bottom. So therefore, they cancel out. What's left on the top? A 4. And what's left on the bottom? X minus 9. And that would be your simplified answer. 4 over x minus 9. Questions about that? Okay, next, x squared plus 8x plus 7 over x plus 1. So, factor first. On the top, do I have any greatest common factor? No, so I do my two sets of parentheses. 7's definitely not a perfect square, so I go with x and x. What's the signs going to be? They're both going to be the same, or they're both going to be plus. That sign in front of the 7 means they're the same. So I look in front of the 8. They're both plus. The factor pair of 7 that adds to 8, 7 and 1. And then my denominator does not factor, x plus 1. Okay, now you do the excluded values. So I take the denominator, x plus 1, and set it equal to 0. subtract 1, x is negative 1. That's my excluded value. Can anything cancel? The x plus 1 and the x plus 1. So my simplified answer would be x, whoops, that's not an x, that's an 8. X plus 7. X plus 7 is your simplified answer. X minus 1, x equals x minus 1 is your excluded value. So on all of these, you factor as low as you can. You find the excluded values from that denominator and you name them. And then you cancel out any common factors from top and bottom. And what remains is your simplified answer. Olivia. This is my excluded value. I do that off to the side so it doesn't get confused with the actual problem. Okay? Zach.
Why didn't you exclude value of x plus 7?
Because it's on the top. You only do the only the bottom can't be 0, remember? You don't want the denominator to be 0. So it was just x plus 1. So you only do the denominator. Anybody else? Okay.